All right, boys and girls, one of the last things that you're going to have to learn this year is how to look at a table and identify what type of function it is. So just a reminder, we've learned a lot of functions. We've learned direct variation functions. We've learned quadratic functions. We've learned exponential functions. We've learned linear functions. We've learned inverse variation functions. Now there's three that you should be able to identify because you know the properties of just by looking at a table of values. Obviously if you saw a graph you'd be able to know what an exponential was, but you should be able to look at a table and know that's an exponential too. You should also be able to know linear. And last, you should know when something is showing quadratic properties. So the first one is one that you did in the very beginning of the year. It's a table where the x's go up by a constant amount, and then if you look at the y's, they also go up by a constant amount. They go plus 6 and plus 6. So when that happens, when the y values are going up by a constant amount, you know that it is a linear equation. So we'll be able to write this equation in y equals mx plus b form. Remember, all you need to do is know the slope and know the y-intercept, and you're going to be able to write that equation in. In this case, because the slope would be 6, the change of y is 6, and the change of x is 2, I know that my slope would be 3 times x. And then in order to find out the y-intercept, remember, you would just either bring x back to 0, or you can do 5 times 3 is 15, and what would I need to go back to 6? So, 15 minus 9. So this equation would work for this one. But just the point is that it is a linear function. Next kind of function. All right, here's a table, and as I look at the table, I notice that the x's are constant. They go up by 1s each time. And then I look at the y's. This goes up 7. This goes up 9. And this goes up 11. So right away you notice that it's not constant, so it's not a linear equation. But when you look at the difference between each problem and you look at the difference of the differences, so between 7 and 9 the difference is 2. Between 9 and 11 the difference is also 2. So when you notice that not that they're going up by a constant amount, but that the difference of the differences is the same, that will identify that you have some sort of a quadratic equation. And this one, which you don't need to know how to do at this point, but this one was from the quadratic x squared plus 1. And you'll notice anytime you square the x value and add 1, you get the y value. But identifying it is what's important. The last one we've already gone through, but just a reminder, when something is a geometric sequence, meaning it's multiplying or dividing by the same number, here we have times 3 each time. Then you know that this is an exponential function. So we'll be able to write it as ab to the x power. In this case, we notice that it already is given as the y-intercept is 3. So that's y equals 3 times. And remember, the scale factor, or what it's growing by, what you're multiplying by is what goes underneath the x. In this case, it's 3 as well. And there's your function. And that's how you identify whether something is a quadratic, linear, or exponential function by looking at a table.